Say it again.
Is that 24?
Is that right here?
Yeah.
That's 20.
Oh.
20. Yeah. Okay. All right. Okay, so parentheses, and inside the parentheses, how many operations do you see? Two. All right, and according to the order of operations, which of these do you do first? Multiplication before subtraction. All right, so I'm going to kind of underline what we're going to do first. I'm going to do this first. Remember, you do one thing at a time. And so I have 3 plus 4 times, bracket, don't forget the bracket, 8, parentheses, and what's 5 times 5? And then you subtract 20. Just do one thing at a time. Write everything else over. All right, this is... All right, now, what do you do next? You're still working within the parentheses, correct? All right, and there's only one operation there, so you got to do it. 25 minus 20 is 5. All right, so one thing at a time. All right, and then now what are you going to do? Now you can do the bracket. So you had two grouping symbols. So you do the innermost first. You're done with the parentheses. Now you have the bracket to deal with. In the bracket, what are the operations that you see? Okay, what according to the order of operations, what do you do first? Multiplication. All right, so 8 times 5 is, so I get 3 plus 4 times, in brackets, 40 minus 41. All right, and then what's 40 minus 41? Negative 1. All right, you learned that last semester, right? Okay, so if you didn't know that, make sure in your calculator you say 40 minus 41, and you'll be what? Negative 1, right? So that's 3 plus 4 times negative 1. All right, and then what do you do next? Well, first of all, what are the operations you have left? Addition, multiplication. According to the order of operations, what do you do? Multiplication. So what's 4 times a negative 1? Negative 4. Negative 4. So we have 3 plus a negative 4. And from last semester, what do you remember about 3 plus a negative 4? What does that equal to? Negative 1. Even if you didn't know that, the way it's written in your calculator, you would say, you would say 3. Well, first of all, your plus or minus button in your calculator, well, the negative button, this right here is the negative button, right here. Right here. That's your negative button. All right. This is your what? Subtraction. Don't confuse that with negative. All right, that's your negative, that's your subtraction. So you're going to say 3 plus, and then negative 4. So you say negative 4, and then press equal, and you get negative 1. Okay? All right. So the answer is negative 1? All right. Okay, number 48. 48.
Same section.
Same section. You have 3/8 squared plus 1/4 plus 1/8 times 3/2. All right. According to the order of operations, what do you do first?
Square 3.
Okay, there are no grouping symbols.
Parentheses.
There are no grouping symbols. I mean, there's a parentheses there, but is that really a grouping symbol? No, because 3/8 is just 3/8. There's no operation inside it, right?
Oh, no.
Okay. So then you do exponents. Now remember 3/8, we talked about that last class period. 3/8 squared means what? 3/8 times 3/8. So if you need to write it out, you write it out. And then from last semester, how do you multiply these two fractions? Multiply numerators together, multiply the denominators together, reduce if you can. It does help at first, at the beginning. If you want to wait at the end to reduce if possible, then do it at the end. But can I reduce here? No. 3 times 3? 8 times 8? 64. So that goes here. So I have 9/64, and then write everything else over. All right, so that's what I have. What operations do I have at this point? Addition, multiplication. According to the order of operations, what do I do next? Multiplication. All right, so if you need to, you may want to cover up everything else. So if I cover everything else, this is what you see, right? All right, and that's kind of like what we just did here. So when multiply fractions, see if you can reduce first. And in this case, I can't. So what's 1/8 times 3/2? 3 over what? 16. Where are you getting 98 from?
I'm sorry, I can't read my handwriting.
Okay, that's all right.
I wrote 3 over 12.
Okay. Yeah. All right. That makes sense. That makes sense where you would get 98. All right. So 3 over 16, correct? All right. So I'm going to write everything else over. 9/64 plus 1/4 plus 3/16. Okay. All right. Now remember, you have access to a calculator. So at this point on a worksheet or a test, you would show all these steps just like this. Okay. Make sure it looks like this. Now the rest of this, if you don't have a calculator, there's a little bit more work you have to do. So let's do this first of all as though we did not have a calculator, just to remind you about some things from last semester that really you need to remember how to do. Okay, so if I carve that 3/16 right here, do you remember how to deal with 9/64 plus 1/4? Remember, let's suppose we don't have a calculator. Say it again. LCD. You have to find the least common denominator. Okay, so you just don't say 9 plus 1 is 10, right? And you don't say 64 plus 4 is 68. That's incorrect. When adding or subtracting fractions, your partitions have to be the same. So 1/64 and the other one is a fourth. You can't just say 64 plus 4. So you have to find the LCD, which brings us to the idea of you're about to write equivalent fractions. So remember last semester you talked about equivalent fractions in 97. All right, so what is the least common denominator? What's the smallest number that 64 and 4 go into? Okay, so remember what I said. What's the smallest number that 64 and 4 go into? Well, it can't be 2 because 4 doesn't go into 2 evenly. Now 2 goes into 4. 2 goes into 64, but 64 doesn't go into 2 evenly. So your LCD, remember your LCD has to be at least as big as the larger denominator that you see. 64. 4 goes into 64. Right? Check and see. What's 64 divided by 4? Is that a whole number? Yeah. All right. Okay. So in terms of these two right here, remember order of operations. So you add the first two fractions first. Your LCD is 64. So now you're going to write two fractions with that denominator. Right, and now we're writing what's called equivalent fractions. So when you write the word equivalent fractions, just to remind you, equivalent fractions. So let's kind of remember what equivalent fractions are. So for example, I'm going to pick a small, an easy fraction to deal with, 1/2. Do y'all agree that 1/2 is equivalent to 2/4?
Yes.
Yes. 1/2 is equivalent to 2/4. Because if I reduce 2/4, I get what? 1/2. Do y'all agree that all these fractions that I'm about to write right here are equivalent? Let's say 3/6. Are those equivalent? Because they're all equal the same fraction. If I reduce all of them, they're all equal to what? 1/2. So 1/2, 2/4, 3/6, and so on. How many equivalent fractions can I write for 1/2? An infinite number. So 9/64, I can write an infinite number of equivalent fractions to it, but I want a denominator with what denominator? 64. Well, these denominators are the same. So 9/64 is equivalent to what fraction divided by 64? 9. It's equivalent to itself. Any fraction is equivalent to itself. So 9/64 is the same as what? 9/64. Now, let's kind of remember this. If I want to rewrite 3/4, and I want to rewrite this with a denominator, let's say 24. Do you remember how you did this?
Multiply 4 times 6.
Okay, so you asked yourself 4 times what's 24? 6. What I do to the denominator, I have to do to the numerator. So 6 times 3 is 18. So 3/4 is equivalent to what fraction? 18/24. All right, so you can do the same thing here. 1/4, I want to rewrite it with what denominator? 64. So 4 times what is 64? 16. What I do to the denominator, I do to the what? Numerator. So 1/4 is equivalent to what fraction?
16 over 64?
16 over 64. And now can I add those two fractions?
Yes.
Yes. So what's 9 plus 16? 25. All right. Now remember, the denominators stay the same, right? You don't say 64 plus 64. All right. So far, this right here, it's just going to rewrite what this is. This right here is going to be what, 25 over 64? All right. Now, let's suppose we did have access to a calculator. So you didn't have, if you have access to a calculator, you don't have to do everything we just did. You could have just done this. All right, so watch carefully. Remember, all I'm doing is just the first two fractions for right now. So all I'm doing is this, and make sure, and remember, if you have a different calculator, you're going to have to read your own instructions, how to deal with this. So you're going to say 9/64 is to say 9 divided by 64 in your calculator, plus, and then the other one's what, 1/4? 1 divided by 4, and now press equal. But when you press equal, what do you get? You get a decimal. Okay. But I need for you to change that to a fraction. All right, so how you get this? How you going to change it to a fraction? You see right above the P or B button, there's a F and then like 2 arrows and a D. That's what you're going to press. Now it's the color blue, let's say. All right, so when you get this decimal, you're going to go to second, PRB, press PRB, and now you see it says F to D. So F is fraction, D is decimal. Press equal, and you get 25 divided by 64. Okay, so that's what this is. See? All right. So you could have, for this right here, so on a worksheet, you show this step, and with a calculator, you can just go from here to the 25 over 64.
Excuse me.
Yes.
Can you explain the calculating thing again?
Is that the calculator you have? Is that the calculator you have?
But I kind of missed it a little bit.
You kind of what?
I kind of missed the end part.
I know. I'm asking, is this the kind of calculator you have? Then I'm not sure how it's going to help you in your calculator, but I'll do it again. 9 divided by 64 plus what? 1/4. 1 divided by 4. What do I press? Equal. Where do I go next? Second. What do I press next? PRB. What do I press next? Equal. Okay. Now remember that those operations or the order in which I did it only applies for this kind of calculator. Your calculator may be different. Okay. All right. Okay. So again, on a worksheet, you can go from this step and then go directly to 25 over 64 just by using your calculator. All right. Now let's suppose though, let's do this again. Let's suppose I did not have a calculator. So then I have to write the 3/16 back. And now this is 25 over 64 plus what? 3/16. All right, so now I've got to find the LCD again. So what's the LCD of 64 and 16, do you think? 16, not 16. The LCD has to be bigger than or equal to what number? 64. Okay? Now, does 16 go to 64, though?
Yes.
Yeah. So what's the LCD? 64. So I'm going to write two fractions. I'm going to write two fractions with that denominator. That one's easy. 25 over 64 is equivalent to what number of 64? 25. All right, so if the denominators are the same, then the numerators have to be what? The same. All right, now let's do this one. Let's write equivalent fractions for 3/16. 16 times what is 64? 4. What I do to the denominator, I have to do to the numerator. 3 times 4 is 12, and now I have the answer. No, no, no. No, no, no. 64. All right. So the denominators are the same, right?
37 over 64
What was that?
would be 37.
Oh, 37. I'm sorry. Yeah. That is 25 plus 12. 37. Sorry. All right. But 60, the denominators stay the same. You don't add the denominators. All right. Now, if I had a calculator, here's what you could have done. So you see how I show this step, show this step? You have to show those two steps. And then since you have a calculator, you can go directly to the answer. On your calculator, you said this. I'm sorry. This was this, right? On your calculator? And now you're going to say 25 over 64. Do a calculator again. 25 divided by 64. Now you're going to say plus what? No, do this one. 3 over 16. What do I press? Equal. What do I press next? What do I press next? What do I press next? Equal. And then what do you get as your answer? 764. Okay? All right. So I think there's one in your worksheet that looks like this. So I'm going to write, show this. Show. And then the rest, you have your calculator. So your calculator, just go from this step to this. Just go to that part.
So
Okay.
when you change your denominator on the one side and you multiply your numerator, why do you not do that the top and bottom on both sides? Why do you only change the bottom and then change the top and bottom on the other one, but not change the numerator?
I'm not sure what you're talking about. What do you?
That's when you change when you multiply I think it was 9 times 16 maybe to get the 64, and then you multiplied that up. When you first did it, yeah.
That's 9 over 64. What do I multiply 9 by?
It's, I think 16 maybe.
I didn't multiply 9 by 16. I don't see anything that says times 16.
When you were changing the 4, is that what you changed?
That's
the 4
this.
to the 64?
Right.
I can't see it. It's my eyes.
Okay, so
So
yeah.
my question is, you multiplied that and then you multiplied the numerator, but you left the other side completely alone.
when you say the other side, you're talking about what, 964? Because I already wrote an equivalent fraction. I already went from here to here. Now I'm going from here to here.
I know, but you're there, I'm higher up. So that's what I'm asking you, so it stays the same is my question.
What stays the same?
The 9 over 64,
You're writing equivalent fractions, okay? So I have these two fractions, right?
right,
I want to rewrite both of those with what denominator? 64. Okay, so this one already has a 64. I'm going to leave this alone.
Right, so that's just my question, you don't change the numerator, the whole thing stays the same.
You know, right.
Okay,
Yeah,
you
so one of the things you got to understand is what we mean by equivalent fractions. All right, so 1/4, I'm rewriting this as an equivalent fraction with something divided by 64.
I understand that part.
Mm-hmm.
I was just, I was told a while back you do both, so that's where I'm confused.
Okay, all right. Okay, all right, let's look at this. Okay, so the next part, you're going to need this handout. An algebraic expression is a collection of numbers, variables, operation symbols, and by the operation symbols I mean add, subtract, multiply, divide, and grouping symbols. So here's some examples of algebraic expressions that you're going to see from now on through whenever you finish taking your college math courses. So like 3x plus 4y. Those are algebraic expressions. They're not equations, because an equation would have what symbol in it? An equal sign. So those are just expressions. Now notice that this expression is made up of numbers, variables, and operation symbols. What's this operation symbol that you see here? Multiplication. What's this operation symbol here? Addition. What's the operation symbol here? Multiplication. Okay? So you could see something like 3x divided by 7. That's an algebraic expression. What's this operation right here? What's this operation? Division. All right, so those are examples of algebraic expressions. All right, now, what you can be doing with these algebraic expressions for the first part here is you're going to, if we give a specific value to a variable, we can evaluate an algebraic expression. All right, so in a little while, we're going to say, what's this algebraic expression equal to if the variable is, let's say, 7, or the variable is, let's say, 4, or -2, or 0, and so on. All right, so to evaluate an algebraic expression means to find its numerical value once we know the value of the variables. All right, so let's look at this example. So this is going to be number 50. I'm going to write it right here on another sheet. This is page 557. Okay, number 50. All right, so here's the algebraic expression. So how do you read this? 4x. What's the operation? Multiplication. All right. So it says evaluate. So if you look at number 50, there are a bunch of problems in that little area, and they're telling you that for each of those problems, for each of those expressions, they're saying x equal 1, y equals 3, and z equals 5. That's what they say. And so they want you to evaluate this expression when x is what? 1. Do we need y and z at all here? No. So the way to do that is you're going to say, in place of the variable, you're going to substitute what the value of that variable is. So this is 4 times x, and what's x? 1. And what's 4 times 1? 4. So your answer is 4. So when x is 1, 4 times 1 is what? 4. All right, so let's look at 54. So 54, you have 6y minus 8. And that's a y. So again, so we have this expression. How many variables are in this expression?
1.
Just one. What is that variable?
3.
No.
Y.
Y, the variable is y. Okay, so if I want to evaluate, I need to know what the value of that variable is. And according to the directions, it is what? 3. All right, so in place of y, I'm going to substitute 3. So this says 6 times y, and what's y? 3, and whatever that is, I'm subtracting what? 8. All right, so all I did at this point was, in place of the variable, I substituted what it's equal to. And now the rest is just using the order of operations. So what operations do you see here? And according to the order of operations, I do what first? All right, so what's 6 times 3? And then what's 18 minus 8? 10. So your answer is 10. All right, 56. All right, you have the absolute value of 5z minus 2y. So the absolute value of 5z minus 2y. So in place of z, what do you substitute? And in place of y, you substitute 3. All right, so I get the absolute value of 5 times z, and what's z?
5.
Minus 2 times y, and what's y? So that's what it looks like, okay? All right, now remember, last class we did something with absolute value, and for right now, just think of the absolute value as a grouping symbol. So I do whatever's inside of it. So how many operations do you see? 2, multiplication and subtraction. How many multiplications are there? 2. You do them in order from left to right. All right, so which one do I need to do first? 5 times 5. So do one thing at a time. So that's absolute value of 25, subtract 2 times 3, right? One thing at a time. You still need those absolute value bars. Now what do I do next? The other multiplication. So 2 times 3 is 6. So I get the absolute value of 25 minus 6. What do I do next? Subtraction. What's 25 subtract 6? All right. And now look what I have. I have the absolute value of 19. You got to remember the absolute value of number. Remember, it measures the distance. That number is from 0. And the distance is always measured in positive terms. So what's the absolute value of 19? 19. So you don't in the blank, don't say absolute value of 19. You got to just say what? 19. All right.
If it would have come out to be a negative 19, would we still make it a 19?
Yep, the absolute value of a negative 19 is 19. Yep, that's a good question. All right, let's look at this one. Now this time, let's suppose that x is 12. Y is, that's y, 8. And z is 4. All right, so this time we're changing the values. This is number 62. All right, 62, you have y divided by z plus 8x. Y divided by z plus 8x. All right, so if I want to evaluate this expression, what do I do? So wherever you see those variables, you got to substitute where those values are, correct? So it's y. So I get 8 divided by, okay, z is 4, plus 8 times 12. So that's where I'm at. So 8 divided by 4 plus 8 times 12. All right. Now, what's 8 divided by 4? 2. All right, so that's 2. So I get 2 plus 8 times 12. 8 times 12 is 96. You do multiplication next. And what's 2 plus 96? 98. So there's your answer there. All right. So let's look at 66. You have, in the numerator, you're going to have y squared plus x. In the denominator, you have x squared plus 3y. So y squared plus x divided by x squared plus 3y. All right, I remember when we did something like this last class period, we dealt with what first? The numerator. So I'm going to go off to the side. I'm going to rewrite the numerator. So I'm just going to rewrite the numerator. And so the numerator here is y squared plus x. All right. Now in place of y, what do I substitute? 8. And in place of x, what do I substitute? 12. All right, so here's what I have. I have 8 squared plus 12. You agree? All right, according to your order of operations, what do I do first? All right, what's 8 squared? 64, good. And what's 64 plus 12? 76, all right. You all agree? All right, now that's what part though? The numerator. So the numerator is just 76. All right, now let's do the denominator. So I'm going to rewrite the expression. My denominator is x squared plus 3y. All right, what's x? 12. So I get 12 squared plus 3 times y. What's y? All right, so what do I do next? All right, what's 12 times itself? 144 plus 3 times 8. And what's 3 times 8?
24.
And what's 144 plus 24? 168. All right, so that goes here. Okay. Now, on my math lab, remember they're going to ask you to reduce, or they expect you to reduce. So what do 76 and 168 have in common? Right. I mean, they're both even, so you know right away it's 2, correct? It could be something bigger than that, but at least you know it's what? 2. So using your calculator, if you need to, what's 76 divided by 2? Okay. And what's 168 divided by 2? 84. So my question then becomes this. Was 2 the largest factor that goes into both of those? No, because they're still both divisible by what? 2. So what's 38 divided by 2? Okay. What's 84 divided by 2? 42. And that's it. You can't do anything else. So the answer you would give would be 19 divided by 42.
Okay, and the 19 over 42 came from the breakdown of both the
38
76.
divided by 84.
Oh, okay, the 38 divided by
Yeah.
84.
So 38 and 84 are both even, so they're both divisible by 2.
Okay.
So 30 divided by 2 is 19. 84 divided by 2 is 42.
Can I ask you a quick question about the one before that, just before you get too far ahead?
Uh-huh.
I just wanna make sure I'm thinking this right. So 8/4 is 2.
Yes.
I guess my first thing I would go to would be like figuring it all out and then equaling it and then dividing it, but is that gonna come out to the same thing?
I'm not sure what you mean, equal, odd, and dividing. What do you mean by that?
Okay, 8/4 is 2, right?
Yes.
So instead of, I guess since it's a fraction, I know it still equals 2, but yesterday you were, or the other day you were saying you wanted everything in fraction form.
No. When we had one like this, 8 divided, whatever, the one that we did, I know what you're talking about. We didn't leave the answer as a fraction because it was a whole number.
So-
8 divided by 4 is exactly 2.
Right, so my question is if I left it like that and then had the 96 and I worked it out that way and then divided it, it would still come out to be.
I'm not sure what you mean, left it like what? Left it like what?
8 plus, what was it, 90, whatever, and then divided it by 4. 8 times 12 is 96.
So you're saying you want to write this as 8 plus 96 all over 12, all over 4?
I'm just asking you if it would come out the same.
No, it won't.
No, over 4, not over.
Well, yeah, 4. 4. First of all, is this thing right here being divided by 4?
No. because it's
No.
not.
So no, it would not give you the same answer.
You wanna make sure your fraction's a whole number.
You want to make sure that well, first of all, this fraction right here is not a whole number. So it's still a fraction.
Right,
But 8 divided by 4 is a whole number.
so what if
It's
it was
2.
What if it was 8 divided by 5?
You can't reduce that. You leave it as 8 divided by 5.
That was my question.
Okay?
I still have a question.
Yes.
When it's 64 plus 12 over 144 plus.
Say it again. I'm sorry.
When it's 64 plus 12 plus over.
First of all, where are you at? 64 plus 12.
You separated the denominator.
Right here?
and numerator. Yeah,
Okay.
I combined them.
What do you mean you
So
combined them?
I had 64 plus 12 over 144 plus.
Where are you getting 144? Oh, you mean this right here?
Kind of like how she wrote down hers, but I put it together. So would you divide 12 and 24? Is it okay to simplify before you add it together? That's what I'm asking.
Okay, so let me write out what you're talking about. So I'm going to write out what you just said. So what did you just say?
64 plus 12
64 plus 12
over 144
over 144 like that,
plus 24.
plus what now?
He just
Plus
did,
24.
he did the numerator and then the denominator and put them together and then he simplified.
Oh, so you're saying instead of doing all this like this, you just went, no, that's fine.
Is it okay to simplify from there? Though?
Okay, when you say simplify, what do you mean by simplify?
Like 12 and 24.
No, you cannot do that. You cannot. You got to add first before you simplify. It's kind of like saying this. If I have 2/3 plus 5 over 10 like this, You cannot say 5 and a 5 is 1, 5 and a 10 is 2. That's not the same thing. It's going to get a wrong answer. Okay? So no, you cannot do that. All right. All right. So you have to add first, and then you simplify after that. Okay? Yeah, so I'm glad you asked that so you don't make that mistake on a test, because you're going to be very upset. All right. But yeah, you could, for that one, you could have done what you did, but you got to add first and then reduce. Okay? Yeah. All right. Let's look at this. Okay, so going back to that handout I gave you, go back to that handout. Let's see if I can find it. Okay, here we go. Okay, so remember that this part right here talks about equations. An equation right here. So just remember, an equation has an equal sign. We're about to talk about equations. You're actually going to solve equations in a couple more sections. But here's an example of an equation. An equation has to have what symbol in it? Equal sign. So that's where two expressions are equal. So you know what an expression looks like. We just worked with expressions. So it'd be something like this. 3x plus 5 equals x. What you need? Okay? So 3x plus 5 equal x. That's an equation. You have an expression equal to an expression, right? Okay? All right. Now go to the next page. Okay, so again, we talked about what an equation looks like. It has to have an equal sign. All right, now, when an equation contains a variable, contains a variable, deciding what values of the variable makes the equation true is called solving the equation. So we're going to look at it. I'm going to start with a simple one. Simple as possible. X plus 3 equal 5. You agree that's an equation? Okay. So now your equations you're going to see are going to be much more difficult than that. But this is something that you had last semester, Math 97. What if I solve this equation, what value of x makes that equation true? 2. Because 2 plus 3 is what? 5. So what I just did was solve the equation. That's the idea of solving. So solving an equation means find out what value of the variable makes the equation a true statement. So x must equal what? 2. Okay? All right. Now a solution, this 2 is called a what? Solution. A solution of an equation is a value that makes the equation true. Okay? All right. Now we're going to look at this. All right, so for this example, here's what I'm going to ask you. I'm going to do the same equation again, x plus 3 equals 5, because you're going to see the same thing on a worksheet. You're going to see the same thing in my math lab. So it's going to give you an equation, and they're going to ask you this question. Is 2 a solution? All right, and you know right away it's what? Yes. So is 2 a solution? You're going to say yes, since 2 plus 3 equal 5. Very good. All right. Then he's going to ask you this. Is, let's say, 7 a solution? You know the answer to that is no, because if I substitute 7 back into the variable, is the left side equal to the right side? No. So is 7 a solution? The answer is no. Since 7 plus 3 does not equal 5. And the symbol for does not equal 2 is the equal sign with that little slash mark through it. You remember that symbol? Mm-hmm. Okay.
And that means not equal to?
Not equal 2. Yep. Not equal 2. So remember, this means not equal 2. Okay. All right.
When you're answering on my math lab, do you have to write it out like no sense? And then
No, usually in my math lab it's going to be
It's gonna be straightforward, like yes or no?
yes or no.
Okay.
Now on the worksheet though, you would have, because there's nothing there, you would have to say no since 7 plus 3 does not equal 5.
All of the worksheets you give us?
Yeah.
Okay.
So when you do the worksheet, make sure you look at these notes. See those people that are absent. You're at a better you're better advantage than they are because they know what it's supposed to look like. All right. Now let's do number 68. So I'm going to go to a blank page, and this will be number 68. And the direction says this. The direction says decide. I'm writing out what the direction says. It says decide if the given number, that's given, G-I-V-E-N, decide if the given number is a solution to the given equation. Is a solution to the given equation. So that is the directions for this part. Okay. Now this is number 68. So 68 looks like this. Here's your equation. That's what it looks like. Then a semicolon, and then 6. Now that's what the problem looks like. So you got to remember what it just says. Decide if the given number, and what's the given number they're referring to? 6. Good. Is a solution to the given equation. What's the given equation they're referring to? 2x plus 7 equal 3. So what they want to know is if I substitute 6 into x, will the left side equal the right side? So the question is, 6 a solution?
No.
Okay, so the way you're going to do it is this is going to be your work. You're going to say 2 times x, and what's x? Plus 7, and you want to see if that's going to equal what? 3. That's what you're asking. Okay?
And you want us to work that to show it doesn't?
Yeah, so you'd say 2 times 6 is 12. So remember, the whole idea of getting to that point is you need to know we had to work with order of operations. So now you know about order of operations. Then we talked about finding evaluating expressions. So that's where we substituted. Now you know how to substitute. So now we're taking 2 things, putting into this one now.
Because it's kind of like what she just asked about. So if it's on your worksheet, we'll put this, but if it asks on.
My math lab is not. Yeah, it's just gonna say yes or no. Yeah, because the My Math lab they can't grade you on what you write. So on a computer, it's usually yes or no. All right, 2 times 6 is 12 plus 7 equal to 3? No. All right. Okay, 74.
First, before we move on, so if we have a problem like this on your worksheet, how would you want the answer written out? Would you want no since 2 parentheses 6 plus 7 does not equal 3?
That's fine, or you can just do what we did. 12 plus 7 question mark equal to 3? No.
Okay, so you can work with it.
Yeah.
Okay.
Yeah. Or you could say no since 2 times 6 plus 7 equal whatever it equals to, and that's not equal to 3. No, you could do it in words. Doesn't matter. Okay? I'm not going to be strict with how you answer this as long as I can see what you're doing. All right, 74. You have x plus 6 equal x plus 6. X plus 6 equal x plus 6, semicolon, 10. All right, so your work.
Yeah.
Right, so they're asking, is 10 a solution? So wherever you see the variable x, you're going to substitute what? 10. So you're going to say, so here's your work. You're going to say 10 plus 6, is that equal to, notice I put equal with the question mark, 10 plus 6. Yeah, 16 equals 16. That's a true statement. So yes. Or she would probably say, well, what would you have done? Based on what you said with number 68, well, how would you answer this?
Yes, since 16 equals 16.
Okay. Right.
I mean, was there other way?
No, it's easy to have just plugged it in. 10 plus 6 is 16, and the other side's the same thing.
So when you have a number and a semicolon like that, it's always, this is what it's always gonna mean from.
Well, not what you got to read. You got to read this part. It says decide if the given number.
But it's always gonna.
You got to read this. Okay. Decide if the given number is a solution to the given equation. So this is the equation. This is the number. So is this number a solution? So that's how you would interpret those directions.
I mean, it makes perfect sense, it's easy, but.
Well,
I'm
it's
wondering
just
how
written-
complicated that's gonna get later on.
Well, the one on the worksheet, I can't remember what it looks like. It's not listed like that, but it's straightforward. You'll see what it looks like when you get it. But I wrote it like this because that's the way I have it in the book, and the same thing in my math lab. My math lab is going to be like this, and then there's no work to do. You just say yes or no. Okay, let's look at this. Write this example. All right, so as example, let's see. Three x minus 2 equal x plus 6, semicolon, 4. So 3x minus 2 equal x plus 6, semicolon, 4. All right, so they're asking, is 4 a solution? That's what they're asking. So your work would be, wherever you see the variable x, you would substitute 4. So 3 times 4, subtract 2, and you want to see that's going to equal, so question mark, equal 4 plus 6. What's the left side?
The left side is, 3 times 4.
Is 12, is 10, so that's 10, right? What's the right side?
4 plus 6.
Which is 10. So is 4 a solution? Yes. So yes. Okay. So 4 is a solution. Okay. Now, in a couple more sections, you're going to be given an equation, and you're going to have to do the process to find what the solutions are. When we get to that point, then we have to go through the next section, which talks about properties. So you need to know about properties in order to get to the solving equation part. All right. Now, turn to the next page. Okay, so remember, one of the other things you've got to be able to do at some point in this course, now next course you're not going to see this, now you will in college algebra, but you also have to be able to solve word problems in this course. Now these are some key words. So addition is straightforward. Sum, plus, added to, more than, increased by, total. Those all mean the operation of addition. Subtraction, difference of means subtract. Minus is straightforward. Subtract from, it has the word subtract in. Less than, 5 less than 8, that's subtraction. Decrease by, decrease, obvious, subtraction. Less, the word less, obvious is what? Subtraction. Now, I want you to put asterisks next to these two right here. Subtract from and less than. Those are the ones that are going to cause you some issues if you don't remember what we talk about when we get to those. All right, subtract from and less than. Those are going to be the two you got to somehow remember how to deal with those. Multiplication is straightforward. Product times multiplied twice. If I say twice, what operation is that? Times what? 2. Times 2. Of, like last semester, you dealt with percentages last semester. So something like 20% of 10. What did that of imply? Multiplication. So last semester when you talked about percents, you had the idea of there. Division, quotient means division. Divide into 7 into 14 is what operation? Division. Ratio is division. You dealt with ratios last semester. The ratio of 8 to 2. That's 8 divided by 2. And then obviously divide by means divide. And then equal. Equals, gives, is, was, should be, yields, amounts to, represents, is the same as. All right. So of all these though, the one that you need to always remember is the phrase subtract from and less than, what do I do? Or it could be numbers. Okay? All right. Now, let's see. Okay, so we're going to do, well, let's just do the first one, and then we're going to have someone come up and do their code. Okay, so the first one says this: write an algebraic expression that represents each phrase. Let the variable x represent the unknown number. Okay? All right, so you're going to use what variable? And x will represent what number? Unknown. The unknown number. All right, look at part A. Product, what does product mean? All right, product of 5 and a number. So how do you write that expression? 5x. Y'all agree? The answer here is 5x. That's what that is. B, a number added to 7. Say it again. X plus 7. X plus 7. Y'all agree? All right. C, a number divided by 11.2. X divided by 11.2. Okay, now let's skip D and go to E. Twice a number, comma, plus 1. All right, so you see that comma? The comma separates two things. Let's do the first part first that's in front of the comma. Twice a number means what? 2x. Whatever that is, you're going to do what? Plus does not mean multiply. Plus means what?
Oh, I'm sorry, I was on the first one. Plus is addition. I thought-
Addition. So what would this expression right here be? 2x plus 1. All right, now let's talk about subtract, the phrase subtract from. Okay, so you had that last semester though. You had the idea of subtract from last semester. So if I say right here, if I say 5 subtracted from 8. 5 subtracted from 8. You know the answer to that. What's the answer to that? 3. But if I write it out, how would I write this out? Would I say 5 subtract 8? No, you know the answer is 3, right? Y'all agree? Okay. So then the question is it 5 minus 8 like this, or is it 8 minus 5? It's 8 minus 5. So the word subtract from, and the reason because 5 minus 8 is what? Negative 3. This is negative 3, and this is what? Positive 3. So the phrase subtract from, whenever you hear the phrase subtract from, you reverse the numbers. You reverse the numbers. So 5 is listed first here, 8 is listed second here, you reverse them. So what did you write first? 8, and what did you write second? 5. All right? So this is what you're going to use. So 5 subtracted from, 5 subtract from, whenever you see subtract from together, whatever, you reverse the number. So whatever's listed first goes second, whatever's listed second goes first. Okay? All right, so we're going to do a little bit more of that next class period, but at least you know about subtract from. Less than is different as well. So we're going to do less than next class period.
8 minus x.
Say it again?
8 minus x.
Oh, I forgot about that. I'm sorry. A number subtracted from 8. I'm sorry. So it will be what? 8 minus x. All right. So subtract from. So 8 goes first. The number goes second. So 8 minus x. Y'all agree?
Yes.
Okay. All right. Let me see if I can give you another worksheet. So this is going to be part B. So I'm going to turn the lights on for a moment. All right. So this is part B.
And then I need to turn in our work from last time.
turn it in Tuesday. Now, if you have it, you can turn it in today, but it's not due until Tuesday.
You want to turn it in, then give it to you now, Mr. Dose.
Huh?
You want to turn it in?
Yeah, just put it right here. Okay, so, all right, let me quickly, we still have 15 minutes. Let me quickly go to this.